Okay, so what we're doing today is making a socket on Gummy. Gummy's our demo patient, thanks for coming.
You're welcome.
So this is a process that's been around in its first iteration. It used to be called ISEX. So it's been around since kind of the 80s and 90s, and ISEX was also direct lamination on the patient. The issue with ISEX was that it was quite expensive, and it was about 90 seconds worth of panic and stress for the prosthetist, which is why it was never very popular. This is the new version called Modular Socket System, or MSS. If you hear me say MSS, I mean Modular Socket System. So it's a lot easier, a lot less stressful, works just as well, if not better than ISEX used to. And it's been around for about 5 or 6 years now, so it's not a new process at all. It's just an ever-evolving process, as we say. It's a benefit for a variety of reasons. One is patient experience. You can come into the limb centre and you can leave in an hour with a socket you can go home on. So in terms of transport, it saves transport for Gummy, it saves transport costs on ambulances as well. And it's kind of used in different ways around the UK and the world actually. It's either used for the more complicated patients, where this is always seen as kind of a bit of the last resort. But I like to see it as a method that can be used for about 90% of people, which then leaves more time for the 10% of people that perhaps need more of the clinician's time. So I'm just going to carry on and do it. Please ask questions as you go. I'm just going to hand Gummy my wedding ring, otherwise I get in lots of trouble. Thank you if I get risen on that. Okay, so these sockets, there's a few different options. We have different grades. We have carbon sockets. There's one of these that's on our stand that we can see. The carbon sockets is just the material that it's made from. It's actually a carbon fibre braid. Put that down there. And we also have glass fibre sockets, which are white material. The main difference between the two, one is cost and the other is cosmetics. So if you're someone that likes to have your leg out, like Gummy does, go for the carbon. If not, then the glass is just the same. Main difference is, say, the look, but other than that, we just do exactly everything the same. Okay, we're casting Gummy over a casting liner. These are reusable liners that are kept on the shelf. And they're just made so that during the process we can't do anything wrong with making the socket. We can just make sure that the socket's as good a fit as we can get. Other than that, we do the same process no matter which liner we're going to fit it with, whether it's a locking liner, so one with a pin, a cushion liner in the sleeve, so suction, or sealing liner as well. So we always use the right size liner, so Gummy has the correct size liner on, so we shall start from here. So the liner's on. All the materials come in a handy box, so we'll just tip everything out. The main thing you get with this kit is a free dustbin, so we'll just put that to there, put everything in there as we go. So Gummy has the casting liner on. Next thing we have is silicone insulating sheet. And this is just to make sure the resin doesn't stick to it, so we're using a polyurethane resin. And with most resins in prosthetic manufacture, they do give off some element of fumes, so you have to do it under extraction. With this method, there's no fumes in the resin at all, which is really nice. It's a specially made resin for us. It's a polyurethane 2-part resin, so it doesn't give off any nasty fumes. Okay. So, 2 sheets of this. This is silicone again. It's the only thing that our resin doesn't stick to. You just have to be careful where you put it, because it does tend to pick up dirt from the floor. And this is made as one size fits all, so we have lots of stretch in this direction, so no matter which size leg you can use, you're using the same sheet. But the way that the material is made, I can't actually stretch in that direction at all. It's a specially knitted mesh, so no elongation that way, plenty of stretch in that direction. And this just gets pulled on like a sock, so we probably don't need all of this. Trim some off. Sharp pair of scissors. If you want, you can pass that around, people can see what it's like. And this, it's got cover on one side, silicone on the other, and we'll just pull that against the liner. So just pull it up for me. Okay. And we'll try to get this quite high just to protect Gummy from any resin that we might get a bit carried away with. Next thing we have is a insulating cap, and this just, because it's silicone on silicone, it will stick to itself, and this just means that the actual whole leg is then insulated against resin. So we just stick that onto the bottom, like so. Quite simple so far. With this process, there is a bit of a stage-by-stage process. We do have a handy flip book. We also have videos online as well. So if you do ever want to go to our website and have a look, you'll be able to see this whole process again. Next thing we put in is our attachment pin, and this is just to attach our casting equipment to. So these sockets are actually cast under pressure, and what this does is stimulate a weight-bearing environment. Let's put it in, it'd be handy, wouldn't it? So we cast under pressure. Once again, it's been a process that's been around for some time. There's nothing new in the ice casting process at all. There we go. It's been around since the 80s, and what this does, it means that it's just stimulating as Gummy's leg would be underweight. So it's basically a hands-off process. There's no mysterious gremlins that can get into this, and there's no human interaction either, other than the whole process itself. So in terms of repeatable fit, the socket that we make today, if someone else made the same socket tomorrow on Gummy, it should be exactly the same, which is a nice thing to have. Okay, so have Gummy properly insulated against resin now. Next we're going to pop the braid on. In the bottom of here, there's 8 holes, and you can see that. And this just enables us to attach different locking systems to the bottom of the socket. So we have different locks, we have clutch locks, so quite quiet ones, we have smooth ones, and we have ratchet ones as well. Equally, one of these holes has a hole in it where we squirt our resin through. So out of one of the 8, it's the only one you can use. And someone did once screw it in the wrong hole and it didn't get very far. So make sure that's in the correct hole. Pull that back. Okay, so next thing I'm going to do, pop the braid on. There's 6 layers of this. It's already tied into the metal adapter at the bottom, so this is what we call the metal puck. Turn that inside out. And we can see here, that's the hole that the resin actually comes through. So make sure that's at the top. Now just to make sure that our puck is square, because this is obviously where we attach our components underneath, and we don't want Gummy's foot at 45 degrees to the socket. It doesn't look particularly great. So we're going to roll all our braid up. It's a knitted braid. All the braids are at 45 degrees to each other, so the more that we pull, the tighter the braid will actually go. So we want a nice firm connection. And then we have a special tool on the bottom, which just goes in one way. Everything gets screwed on. Okay. Next thing we have is just some really fancy B&Q electrical tape. And you just put that around here. It just helps stop the 2 parts sticking together. And then finally, one more layer of silicone insulating sheet, but this time it goes on the other way around, so it goes silicone side in. Once again, we don't need all of this, so we just trim off what we don't need. Turn it inside out, and then we just roll it on like a line. Okay. Yeah. Next thing, we're just going to tape this silicone to the other piece of tape that we've put on, and then it just seals the whole system from leakages. It's tricky not to get the pieces in here. Off and then trim that off. Okay, so now Gummy's ready to go. Next thing we're going to do, take our resin cartridge out of the packet, give it a shake. These have a shelf life of a year, so generally they get used before they get out of date, so just be careful with the use by date. And then it's just a sealed top.
Yeah, no. Good bin.
The resin comes out of a plastic tube that has a kind of helix on the inside of it. So it's got a mixing tube inside the actual ejection tube. And this just means when the 2 parts of the resin come out that they mix each other together really well before they get into the material itself. It's a very runny resin, so as soon as you open it, you have to keep it pointing back up the way again. Push our tube back on. Okay. And then we have a special injection gun. It's just a 2-part plunger. It's like your silicone gun that you use in your bathroom, and this is just what we use to clip the resin cartridge. Ready?
I'm ready. You are?
One ready. Okay, so we just reconnect our resin tube to the cartridge at the bottom, and then squeeze. And because it's a yellowy resin on the white braid, you can see where it starts to come out. So as the resin sets, it gets to about 35 degrees, same as a nice warm bath. So it's not like it gets really, really hot. We did have a previous version of this that got quite warm. And it's a very runny resin, so we're just using a plastic tube just to string it up the braids itself. So it's quite a nice process. You can't really feel what I'm doing because there's plenty of insulation between me and the actual resin itself.
It's comfy.
Comfy, good.
Get a massage.
The good thing about using the whiter braids is that you can see how far your resin has actually been strung up.
So the black you can't see.
You can, it's just dark on darker basically, whereas this one is actually quite obvious where your resin has actually got to.
Does that handle bumps and lumps in your stump
Yeah,
quite well?
yeah, it's a very fluid resin, it's a very fluid braid. We're not actually, by the time that we roll our casting equipment on, it's still very liquid. Whereas the issue with the other method was that we had it was kind of half set before we used to roll our casting equipment on, which was never really that good because then you were forcing half set material onto bony prominences. This one is much smoother. You get a really good anatomical fit. Oops. Got the back cleared. Okay, so we've got our resin up to where we want our trim lines. To take it off, we just release a bit of pressure on the gun. Drop the end down and then the resin will flow back into the tube so we don't get too many drips. Just disconnect. Look at that. Okay, then our casting equipment is basically a large inflatable bag, to put it bluntly. And all that happens is this will once again smooth out the resin process on the resin thickness on gummy. So we just reconnect this. As it rolls up, just deflate it. Inflate it down to nothing almost. Re-inflate again. And there's a pressure gauge on the bottom. So if you want, depending on tissue consistency, you can make a slightly tighter or looser socket. Normally go to about 90. Disconnect. That's it. Just reconnecting the pump again. Just deflate. The bladder rolls off. You can see it's now set. So to take these off, all we need to do is just pull the top layer of silicone sheeting off. Loosen up in. Thank you. We'll just put some rough trim lines on here where we're going to cut the socket, which we can do now as well. Under our attachment. Put everything down. And then here's the colours. So now, socket's finished. All we need to do is trim the top edge and then we can bolt it onto Gummy's leg and you can walk away.
Can I?
Yeah.
I'm walking home then. How long does it take?
Off.
Speed limit for that, for the socket.
166 kilos,
Right.
25 stone in real money.
Is that stuck to the mesh now? Is that white mesh, is that part of it?
Yep.
So that's it.
It's gone all the way through.
All the way through.
Oh, it goes through the mesh?
Yeah, it's like the resin goes through the braids. So the resin is like the part that makes it go stiff, and then the braid is there's like the strength element of it.
Ollie, hi, behind you.
Oh, hello.
Is it just for the pin sockets?
No, you can use it with sealing or cushion liner in the sleeve as well. So you can, and the benefit is that if you want to change down the line, you just have to change the distant adapter, keep the same socket, because you do the same process no matter what liner you're going to use.
Is it usable above knee as well?
Not yet, we're working on it. Yeah.
Oh yeah, the lock is just there. Sorry, mate.
So obviously in a clinic you'd spend more time doing this than perhaps I am now. Take the rough edges up. Okay. On the bottom we're just going to bolt lock on.
For about 15 sheets.
So just as we're looking at these two materials, these are just two materials and there are other materials available, but the idea is that materials are moving on. You know, next week there'll be something else. Not so long ago I wouldn't really have used a mobile, and now I use a mobile. We change what we do. And so the hand orthosis material that Elaine has been working with might not be suitable for a leg because it's not strong enough, but there are alternative materials, and you can see that as well with Allard, and thanks to Allard for providing this today. But actually things change quite a lot, and so we can move on from there. From Ollie's side, I think that the laminate materials are interesting because the material that is inside can be different, and the resin can be different. So again, it's just thinking a little bit how these are and just seeing what they are. We hear about these things, but I thought it'd be useful to see them. And the fact that Elaine and Ollie are working on this so that Gummy and Colin can be walking and using these later on today is pretty good. So just to just show you what's around. And I've left this little fish at the front, which was made from a laminate, something like this, just a little bit artistic. This is Harry Kinsman, who's a technician who's not here today, and he decided, well, people go swimming and they don't really want their leg on. But it's a bit embarrassing to take your leg off at the local pool sometimes, especially for kids. So why not make a fun thing so the kid could swim with the fish, you know? So this was just a prototype that we did some years ago now. So there's just some, you can play with materials, and that's just wanted to show you some of the materials today, and also to show you what is possible and what isn't possible. So maybe for different reasons you might use different materials. So I'll just hand back over to Tony.
On the right hand.
So I think our experts have made this look very, very easy today, in actual fact, and as you might imagine.
Ready?
Are you ready?
Yeah.
Okay. So it's pretty amazing to think that the socket is now ready for a trial walking, and
Is it comfy?
Yeah. I don't use them, but I like it. I can't believe you got almost the same. I need to line it up a bit, but it's so close. It's unbelievable.
are there any downsides to this type of socket, Ollie?
No, not especially, to be honest. I mean, the only people it's not suitable for are those that have kind of flexion contractures or more have an abduction than perhaps you can deal with adapters, to be honest. But there's no reason why it shouldn't fit. Of course, we made it 10 minutes ago, so all we're fitting is what we had 10 minutes ago, so there's no reason why it doesn't fit at all. And generally, these sockets last quite a long time because they are comfortable from day one. You're not forever trying to modify it to make it better, because it's 100% from the word go.
And I suppose it's taking the variation of the process, dare I say, speaking as a process, out of the equation, because it's done with the pressure cast.
Absolutely. I mean, it's, as you said, it's not my first time. There are things you can do wrong in the technique, but the system itself should be pretty much standardised. In fact, it's so much standardised we've actually CE marked it because it's a standardised process. But in the whole process, it's mainly the pressure casting element that people aren't that confident with, and that's what they tend to get wrong. But generally, it works the first time.
How strong is the resin compared to carbon fibre?
Well, we use the same resin. The carbon fibre is the braid. So this is carbon fibre, but the weight limit's the same. The only difference is that carbon's 4 layers thick and the glass is 6 layers. Other than that, they're rated to the same weight. So there's no difference in weight limit at all.
So it's just a cosmetic.
Yes.